All right, let's dive in. We're going to be exploring Docker, Kubernetes, even a bit of AWS and Groovy pipelines today.
Sounds fun.
If you want to really streamline your development workflow, I think you're really going to enjoy this deep dive.
Yeah, definitely a lot of cool stuff we can talk about.
For sure, we're going to uncover some neat tricks, like shrinking Docker images to make things more secure.
Yeah.
And, just understanding how Kubernetes keeps your applications running smoothly.
It's amazing how these technologies have really shifted the way we think about developing software these days, you know?
Totally.
It's not just writing code anymore. It's like building this whole ecosystem where your apps can actually thrive.
Yeah, for sure. So let's start with Docker. I was reading about multi-stage builds, and I admit it's a pretty clever concept.
Yeah.
It's like, you're packing for a trip, and you only want to take the essentials.
Right. Exactly. Multi-stage builds, they let you create these really lean Docker images. You see, when you build an application, you often need all these tools and libraries that aren't really necessary for it to actually run, you know?
Right.
So with multi-stage builds, you can separate the build process into these distinct stages, and you only include the bare minimum in your final image.
Gotcha. So besides smaller image sizes, what's the real advantage there? Faster downloads.
Well, yeah, faster downloads are definitely a benefit, but the real game changer is security.
Okay.
By taking out those unnecessary components, you're reducing the attack surface of your app.
Makes sense.
It's like locking down your luggage so only you have the key.
Right.
Fewer things in the image means fewer things for an attacker to exploit, right?
Yeah, totally makes sense. But I imagine setting up multi-stage builds can be kind of complex. Is there a trade-off there, like complexity versus benefit?
Well, there's definitely a learning curve, but once you get the concept, it becomes really powerful.
Okay.
Think of it like an investment. You're spending a bit more time up front to design your Docker files strategically. But the payoff is huge in terms of security and efficiency.
Okay.
Plus, there are tools and techniques that can actually simplify the process.
Okay, I'm intrigued. Now, let's say we have our streamlined Docker image. It's ready to go.
Yeah.
How do we actually get it running on multiple servers?
That's where orchestration tools like Docker Swarm come in.
Okay.
Imagine a conductor leading an orchestra.
Okay.
Each musician has a specific role, and the conductor coordinates their actions to create this harmonious sound.
Right.
Docker Swarm does the same thing for your containers.
Gotcha.
You define the state of your application, how many replicas you need, and Swarm handles the deployment, making sure those containers are running across your service.
So Swarm's like the conductor of our container orchestra.
Exactly.
That's cool. What about communication between those containers, though? I've heard things like bridge networking and host networking. What's the difference, and why should we care about that?
We'll think of bridge networking as each instrument having its own sound booth. Each container gets its own IP address, and it operates in isolation.
Okay.
They can still talk to each other, but the communication is controlled and it's secure. Host networking, on the other hand, is like putting the whole orchestra in one giant room.
Okay.
Containers share the host's network, which can be more efficient.
Yeah.
But it also reduces isolation and security a bit.
Gotcha. So bridge networking for isolation and security, host networking for performance. It's like choosing between a recording studio and a live concert, depending on what you need.
Exactly.
Okay,
Yeah.
cool. Okay,
Yeah.
So we've got our Docker containers all orchestrated like a well-rehearsed band.
Right.
But what about Kubernetes? It seems like everybody's talking about Kubernetes these days.
Yeah.
What makes it so special?
Kubernetes kind of takes that container orchestration to a whole new level. It's super robust and feature-rich, designed to handle all the complexities of deploying and managing apps at scale. One of the coolest things, I think, is its ability to keep your apps running smoothly,
Right.
even when things fail.
Sounds like a superpower that every developer dreams of.
Right.
How does Kubernetes actually achieve that, though?
Well, it uses a lot of different techniques, including something called liveness probes.
Okay.
Imagine you're at a concert, and the band suddenly stops playing.
Oh, no.
A liveness probe is like a stagehand checking to see if the musicians are still on stage and, if they're still performing.
Right.
So if a container becomes unresponsive or unhealthy, Kubernetes will automatically restart it. And that ensures that your application stays up and running.
So Kubernetes is like a vigilant stage manager, constantly monitoring the performance, making sure everything's running smoothly.
Yep.
Pretty cool. But what about scaling? Let's say our application suddenly gets super popular. We need to handle like a huge surge in traffic.
Yeah.
Can Kubernetes handle that kind of dynamic scaling?
Oh, absolutely.
Yep.
Kubernetes makes scaling super easy.
Okay.
You can define how many replicas of your app you want, And Kubernetes will automatically adjust the number of pods based on the demand.
So it's like having an army of stagehands, ready to set up more instruments or microphones
Right.
whenever the music gets louder.
Exactly.
That's amazing. Sounds like Kubernetes takes care of so much behind the scenes. But what about us developers? Do we have any control over that deployment process?
Oh, for sure. That's where tools like Groovy pipelines come in.
Okay.
Imagine a choreographer designing a sequence of steps for a dance performance.
Okay.
A Groovy pipeline defines the steps for building, testing, and deploying your application.
Right.
You can customize every stage of the pipeline to fit your specific needs, and you can even integrate manual approval steps to ensure that deployments only happen when you're ready.
So Groovy pipelines give us that fine-grained control over the deployment process.
Yeah.
Can you give me a concrete example of how we might use a Groovy pipeline to deploy like a Java Spring Boot application?
Sure. Let's say you have a Spring Boot app that you want to deploy to a Kubernetes cluster. Your Groovy pipeline might have stages for like checking out the code from your repository, building the application, packaging it into a Docker image, pushing that image to a registry, and then finally deploying it to your Kubernetes cluster.
That makes sense. It's like a carefully choreographed sequence of steps,
Yeah.
taking our application from source code to a running deployment.
Yeah.
But what about testing? How can we integrate testing into our Groovy pipeline to make sure we're only deploying high-quality code?
Oh, yeah. You can totally add a testing stage to your pipeline where you run your unit tests, integration tests, any other automated checks you have in place.
Right.
And the cool thing is you can configure your pipeline to only proceed to the deployment stage if all the tests pass.
So it's like having a quality control checkpoint built right into our pipeline.
Exactly.
I love it. What happens if a test fails, though? Do we have to, like, manually investigate the issue?
Not necessarily. You can configure your pipeline to generate detailed test reports. Even send notifications to your team if something fails.
Okay.
This way you can quickly identify and address any issues and make sure that only thoroughly tested code makes it to production.
That's really helpful, like having a feedback loop that alerts us to problems early on in the process. Before we wrap up this part of our deep dive, I want to go back to Kubernetes for a second. You mentioned earlier that it can handle failures gracefully.
Yeah.
Can you elaborate on that? What happens if a server in our cluster goes down?
Kubernetes is actually designed with redundancy in mind. You can configure it to run multiple replicas of your app across different servers.
Right.
So if one server fails, Kubernetes will automatically redirect traffic to the remaining healthy replicas, making sure that your application stays available.
So it's like having an understudy ready to step in if the lead actor gets sick. That's amazing. Sounds like Kubernetes has thought of everything. But with all this talk about containers and orchestration, I'm thinking about the underlying infrastructure. How do we manage all the servers, networks, and storage that our containers run on?
Yeah, so we've got these amazing tools, Docker, Kubernetes, handling our containers and orchestration. But what about the stage itself, right? How do we manage all that infrastructure underneath it all?
That's where these infrastructure as code tools like Terraform really shine.
Okay.
Imagine you're like building a stage with the script.
Okay.
You define exactly what you need, the size, the layout, even the lighting. And Terraform turns that script into reality. It provisions your servers, your networks, your storage, everything,
Wow.
everything your application needs.
So Terraform is like the stage crew, building and managing the entire infrastructure based on our specs.
Exactly.
That's incredibly powerful. But I've heard that managing Terraform can get a little tricky, especially when it comes to these things called state files. What are those, and why should we care about them? State files are like blueprints for your infrastructure.
Okay.
They keep track of everything that Terraform has created, so it knows what needs to be changed, updated, or destroyed. It's super important to manage these files carefully
Oh, sure.
because they're really the source of truth for your infrastructure.
So it's like a constantly updated record of our infrastructure. A bit like a conductor score that evolves with the performance.
Yeah, I like that analogy.
But what happens if we mess up that state file? Could we like accidentally delete our entire infrastructure?
That's a great question, and it shows why state file management is so important. Accidental deletions are a real risk, which is why we have best practices like remote state storage and locking.
Okay.
Remote state means storing your state file in a shared location, like an S3 bucket,
Right.
so everyone on your team's working with the same info. And locking prevents multiple people from making changes at the same time,
Okay.
which could corrupt the state file.
So remote state and locking are like safety protocols, preventing us from accidentally like tripping over the conductor stand
Yeah.
and ruining the whole performance.
Exactly.
Okay, that makes sense. Let's go back to Docker for a second. We talked about deploying those containers across multiple servers using Docker Swarm.
Yeah.
What if we want to make sure certain containers always run on the same server? Is that even possible?
It is. Docker Swarm lets you define constraints for your services.
Okay.
You can specify things like which hosts a service should run on, what kind of resources it needs, even dependencies between services.
Okay.
For example, you could say that your web server container has to run on a host that has a specific amount of memory, or that it should always be co-located with your database container.
So it's like having a seating chart for our containers,
Right.
making sure they're always in the optimal configuration.
Exactly.
That's pretty cool. What if we're using Kubernetes, though? Does it offer similar capabilities?
Oh, absolutely. Kubernetes actually has even more sophisticated features for controlling placement. You can use something called node affinity
No.
to say that certain pods should be scheduled on nodes with specific labels.
Well,
For example, you could label a node as having high-performance storage, and then tell Kubernetes to only schedule pods that need fast storage on that node.
that's incredible. It sounds like Kubernetes gives us a lot of control. But with all this power, there's also complexity, right? How do we keep track of everything and make sure our deployments are running smoothly?
Well, that's where monitoring and observability tools come into play.
Okay.
These tools let you collect metrics, logs, and traces from your apps and infrastructure,
Okay.
giving you insights into performance, resource usage, and potential issues.
So it's like having that team of stage managers
Yeah.
constantly monitoring the performance,
Yeah.
identifying any problems,
Exactly.
alerting the right people. That's essential. As we wrap up this deep dive, I want to ask you a broader question. What do you see as the future of containerization and orchestration? Where do you think these technologies are headed?
That's a good one. I think we're really just scratching the surface of what's possible. As these technologies mature, they become more widely adopted. We'll see even more innovation, more creative use cases. I
Yeah.
think we'll see a shift towards more serverless platforms
Right.
where developers can just focus on writing code. No worries about managing infrastructure.
That sounds like a developer's dream, a world where we can just write code, let the platform handle everything else.
Right.
But what about security? Will serverless platforms be secure enough for really important applications?
Security will always be a top concern, and these serverless platforms are going to have to evolve.
Right.
But I'm optimistic that we'll see advancements in areas like container isolation, secure supply chains, automated security scanning, making those serverless platforms even more secure and reliable.
That's reassuring to hear. Sounds like the future of software development is really exciting, with containers and orchestration playing a key role. Well, we've covered a lot of ground today, from the basics of Docker and Kubernetes to the importance of managing infrastructure as code and security. I hope you've come away with a deeper understanding of these powerful technologies and how they can really transform your development workflow.
It's been great exploring these topics with you. From streamlining your builds to orchestrating deployments, managing your infrastructure, the tools and techniques we talked about can really help you build and deliver incredible apps.
Absolutely. And remember, the world of software development is constantly changing. So stay curious, keep learning, and don't be afraid to explore these new, exciting technologies. Until next time, happy coding.